This is the last in a series of 6 videos talking about simplifying radicals. This episode is going to be talking about adding and subtracting radicals. What you have to do is, in order to add or subtract radicals, is they need to have the same radicand, the same number on the inside of the radical. At this point where we're at, we do not have the same number here. So what we need to do is we need to break this down. So this becomes 3 and 9. This is 3 and 3. When I simplify this, I look for my pairs. That's 3 times the square root of 3. When I break this guy down, it would be 25 and 3. This is 5 and 5. I look for pairs. Ooh, there's a pair of 5s. So I have 5 times the square root of 3. If you look at these, they both have the same square root of 3. So if I have 3 square roots of 3 and 5 square roots of 3, I have a total of 8 square root of 3. And that's how adding and subtracting radicals work. First you break down the radicals, such as this would be 4 and 8. This is 4 and 2. I have a pair of 4s, so I have 3 times 4 is 12 times the square root of 2. This breaks down to 4 and 2, which is 2 and 2. I have a pair of 2s, so this breaks down into 12 times the square root of 2. If you have the square root of 2 and square root of 2, I just take 12 minus 12, which should give me an answer of 0. That's kind of sneaky, that these two numbers are actually the exact same number, just disguised as different numbers. Sometimes you have more than one, and sometimes you're going to be left over with some extra stuff. So if I break down 12, remember that's 4 and 3, and that breaks down to 2 and 2. So I have a total of 2 times the square root of 3. 48 breaks down to square root of 16 and 3. So this will give me a pair of 4s. So I have minus 4 times the square root of 3. Then I have just plus the square root of 3. I like to think about this having a coefficient of 1, and then I just work with the coefficients. 2 minus 4 is actually negative 2, plus 1 is just negative 1, so I have negative 1 times the square root of 3. Or probably the best way to write this is just negative square root of 3. The 1 is understood. The same thing happens when we have variables inside. We'll just break this down. This would be 9 times the square root of x plus 5 times the square root of x. 9 plus 5 is 14 square root of x. That'll be my final answer. Let's look at just a few more of these. I can break down 12 into 4 and 2. This is 2 and 2. I have a pair of 2s that'll join my 3 on the outside, so I have 6 times the square root of 2. And then I have 6 times, oh man, this is going to be a mess. 6 times 1/3. Not even sure what I'm going to do with this guy. I guess we just break this down to the square root of 1 over the square root of 3. Let's see what happens. Square root of 1 is 1, so it basically just goes away. I'll have to rationalize this part of this by saying this is the square root of 3 over the square root of 3. That would give me 6 times the square root of 3 over 3. And that simply breaks down, since those two are both divisible by 3, I'd have 2 times the square root of 3. At this point, I have 6 times the square root of 2 plus 2 times the square root of 3. And those really don't combine because they have different radicals. So I'm just going to say that's my final answer. And if someone were to write this as 2 times the square root of 3 plus 6 times the square root of 2, there's really nothing I can do about it. It's going to just be that type of answer. So be careful when you have fractions like this. Just realize that puts the bottom of the fraction, the denominator of the radical, on the bottom or the denominator of this fraction. Our last one's really easy. We have the square root of y and the square root of y, so I'll just take 14 minus 9. That gives me 5 times the square root of y. Hope that this helped. If you need to check out some of the other videos, please check them out. Good luck with the radicals.